Microservices. So first of all, I'm Giovanni Asproni. I wrote this presentation with Steve Freeman, who is a colleague and also quite well-known guy in our world. And this is about microservices. It's a talk based on our own experience working with those. So, you know, when we think about microservices, we think about things that we can create, let's say, in a few lines of code within a week and provide the service just there and then, you know, to our users. So the thing is also that when we have a service there, providing some useful functionality, we also need to support it somehow, support the lifecycle and everything. But when we talk microservices, we have a fleet of these things. So we talk about some of the issues that come with this. But first of all, this is Steve Freeman. As it happens, he's actually one of the inventors of the mock objects. And this is a book that we wrote with enough price about test-driven development, which if you do test-driven development and want to improve that, this is the best book you can possibly get about it. Okay? But let's start with the microservices. So first of all, a show of hands, who has done any microservices architecture in the room? Just a few. Who is thinking about using them? Who thinks it's just a part, or just? Interesting, the ones that are using them. Let's move on. So, usually, when people talk about microservices, they think, you know, we're in technologies because we want to gain something out of those. I have to say that there's a bit of a problem now because they generally tend to move a lot and are going to die probably quickly. So in case of microservices, having several services providing some functionality, you know, usually is flexibility of delivery. So you don't need to deliver everything in one go. Yeah? As soon as some services are ready, you can provide some functionality, you can put it there. So you don't need to wait for the entire application to be ready. Okay? You can do that bit by bit. Or flexibility of deployment, yeah? Which happens to be actually a double-edged sword, this one, because this means that in theory, you should be able to actually deploy the microservices in a way that is independent from each other, but it's not always that obvious, because then we talk about maybe the protocols on those services and things, but in theory, there is a good way of basically deploying a service without, again, affecting other services that you are providing, yeah? And you deploy when they're ready. And also, you always have something that is always working, system that is always available. The idea is that you don't need to bring down all the services to deploy a new one, you just deploy the new one, whatever was there is still there, you don't need to bring down the system. In many systems, this is quite important. To give you an idea of systems that have to be up 24/7, the one in which it might die. We are colleagues and are working the same project at the moment. We have to support, when we update with a new version, the system, we have to do that in a way that is up all times. We cannot bring it down. Okay? It's a very important system in a bank. If it goes down, people in the bank get upset, and for this particular system, even the regulator might get upset, which is not good. So microservices can allow you to do this kind of thing. Flexibility of response, so there is tolerance of failure as well. Yeah, something goes down, but the rest of the service is available. So it's not there is a bug in a particular piece of functionality, or a call down, everything goes, crashes and burns, and your users will be really upset. Yeah? And also, depending on how you do them, tolerance, failure, and locality. So the failure has to happen in one place. You don't want this to go all over the place. It's much easier to keep the failures local. Yeah? Flexibility of implementation. Typically, when you work with microservices nowadays, they talk with each other using REST protocols, and so each service can be implemented with a different language, different technology, depending on what is best for the particular service. Okay? And then, last but not least, flexibility of employment, CD-driven development. Yeah, this is when people go to learn doing microservices in an agile environment with DevOps and stuff, but they don't really know what they're writing. But it's interesting for recruiters. Yeah? So, like all things, in our sector, when they're new, they always sound great. Yeah, you can do all this cool stuff. You can deploy things that work. The system is always happy. Everybody's happy. Everything is fine. Unfortunately, you know, in a great lunch, often there are people in the kitchen that are actually keeping the system alive, and they might have a slightly different view of what is happening. Okay? So, organizations really need to set up some really serious infrastructure to support the microservices environment. Okay? Because we'll see there is a lot of automation to be put in place. There is lots of supporting infrastructure for managing the microservices themselves. Okay, so the perceived benefits don't come for free. Yeah? And in a way, as you know, following from Timo's keynote, actually we had this story before. Because again, all these, you know, every new technology, new thing was always to basically simplify the same thing. So many arguments about the microservices were done about object-oriented programming, for example, or about Corba. Who in this room has ever used Corba? Yeah? Distributed services with objects talking with each other and stuff like this. Yeah? There are many of the same ideas. Yeah? Or software reuse as well, using service for doing several things. But in a way, we are approaching the problem again in the usual fashion. Yeah? And the thing is that now we see that also in microservices, as with these other things, sometimes people see what is understand the surface of the technology, but don't really look in depth about what the consequences are. So with microservices, we are also talking about systems in a network. Yeah? So we are talking generally about distributed systems. This is Leslie Lamport, one of the most important guys in distributed systems. He once said a distributed system is one in which the failure of a computer you didn't even know existed can render your own computer unusable. Which happens every day in big corporations, by the way. Yeah? So, as you see, when you have systems in a network that interact with each other, you may have new problems to deal with. Yeah? If everything is running the same program, you don't have the problem of the distribution. So,
just an observation, it doesn't even have to fail. You just have to have a timeout on a security certificate.
Just from random experience.
That's random.
Yeah. Something like that. But basically the idea is there will be a new set of problems to deal with. So we are not simply solving existing problems, we are introducing new ones. Okay? And so sometimes there are some things that can go really, really wrong. Okay, this is a microservice that actually caused some trouble and the machine room exploded, as you can see from Oliver Hardy there. So there could be surprising failure modes. Distributed systems fail, sometimes we call also Byzantine failure, things that you can have situations where several small failures happen at the same time and everything goes on fire and nothing works anymore. Yeah? And they can be really difficult to actually avoid or even to diagnose. Additional complexity due to distribution. The simple fact that there are many parts in moving parts. This adds complexity because they have to work together. Yeah? But when they don't, you have an issue. Imagine situations like one service hangs, you request another one, files a request and then waits forever. This is the kind of failure that may actually cause the entire system to block. Okay? This kind of failures usually don't happen in a single process, but when you have a network, this is kind of a common case scenario. Yeah? So you may have to introduce circuit breakers like timeouts. Like try within 500 milliseconds to get a reply and say, okay, declare the system, the other system died and do something else, for example. Things like this. Mistakenly share resources, or sometimes by design because people sometimes don't understand what they are doing. So a typical example is the microservices that actually share the same database instance. Okay? So we are not talking about the same schema necessarily, but the same instance, which is a typical mistake, and let's see this one, because basically what happens in those cases, the database becomes the single point of failure. So instead of having a system that is fault tolerant and high available because if part of it fails, the rest is actually working, in this case, if the database fails, you have a problem. And you can't imagine how many microservices architectures are implemented like this. Okay, so one thing to keep in mind, again, if you want several services working with each other, and you don't want to increase the possibility of failure, you also have to keep them autonomous somehow, so they communicate with each other, but they don't really share resources. Yeah? Or one service to rule them all. Yeah? So there's, again, it's another aspect, a similar aspect of sharing the data, because in this case, it's the main service where it is the only entry point for the system, and then communicates with all other services. Again, you have a single point of failure that actually just makes the whole point of microservices just worthless. Yeah? If you have a system design like that, probably don't even want microservices, or just adding complexity without really gaining any benefits. Yeah? I actually, in a recent systems, when I worked on it, there were all these problems at the same time. We fixed them. The original team, they were very young, not very experienced in terms of services, but they went for the microservices because it was the new cool technology, and that they had this kind of hit all these problems. Okay? And there are other things that are a bit more subtle. So typically, a thing that happens with the microservices is there are many things involved. So the typical idea is with a couple development, so each thing will take care of a different service. Trouble is that depending on how your system works, maybe different services need to interact with each other to provide some useful functionality to the end users. And if you have these kind of scenarios, they need to interact with each other. Yeah, they will have to agree on something on how to implement this functionality. And this means agreeing on who is responsible for what, which adds quite a thick layer of complication. Okay? Even in many companies that claim to be agile, you see a reflection of this problem in situations where you have each team with its own backlog, separate from the other teams, but there is no unifying backlog about the functionality the user really wants. Yeah? So the sharing of responsibility is actually quite unclear, and it's extremely difficult to figure out when the functionality will be actually done. And this is, again, a typical problem. Or premature service partitioning. This means you are creating a, let's say, greenfield system in a particular area. And instead of starting from trying to understand the problem and then build a solution from small one and then growing it up, is we'll go with a microservice architecture. What problem you are going to solve with that? A consequence of this kind of decisions is that often the partitioning happens along some lines that seem sensible for some definition of sensible. So, for example, a system worked on where we had to track people to protect them from danger. For a customer of Zurich was a company that provides a very niche service. This one, they do travel protection. Not travel protection as in EasyJet insurance or ANF, travel protection as in people go to dangerous places like Iraq, Iran, working for BT, stuff like this. There is a terror attack, okay? They need to actually find those people and tell them what to do and sometimes evacuate them, okay? So one system we have building this has several aspects. There is where the tracking of people, there is the aspect of actually having geographical data for countries.
Sorry, I can't hear you.
I'll move here. Is it better?
That's better.
Do you want
I'll stay here.
Do you want a Britney mic?
That probably would be, yeah, sorry, I tend to move. Thank you. So there are several aspects that initially seem to be kind of logical division of putting countries in a service, people in another, and things like this. The trouble was that keeping this split was not working because you had to provide...
This requires some doing, so for everyone's benefit, one of it goes over 1 year, the other goes over another year.
Oh, God.
The
This
mic
is-
sort of comes here, and then this hangs off somewhere, say.
Like this.
Yes.
Okay. Can you...
Hang on. But so long as they can hear you,
can you hear me now? Can you?
Yes.
Okay. And so sometimes some split, if done too early, actually may seem sensible according to some, we have countries in a service, we have people in another one, we have alerts, and alert is basically a bomb goes off somewhere with some information about the place and other data somewhere else. But then you have to implement it, create a service functionality that says, I want to know all the alerts at this time in this country. Or things like, I want to know the people affected by this alert. So queries that actually go to use all your services. And with a premature partitioning, what happened was the only way to do this kind of queries would have been query everything from every service and basically do a join in memory. That if you are protecting 3 people with 2 alerts in 5 countries, might be fine. Okay? The number of countries that we had classified were 208. Alerts there were dozens per day, and people were talking 1,000. Okay, so there was a premature split of the service based on some theoretical, logical understanding, but was not actually the correct domain for that particular functionality we needed to provide. Okay, and this is quite a common problem. Yeah, when a similar problem, for example, when I was working in a European Bioinformatics Institute with lots of biologists, that they tended to do object-oriented programming with the typical thing. The animal, a man is an animal, a lion is an animal, the class animal at the top, the kind of object-oriented program that used to teach us somehow. Forgetting that depending on the domain, you might be interested in the fact that something is a mammal, or you might be interested in the fact that something can be actually butchered for eating. Okay? So depending on the domain which you are, some classifications are useful, some others are not. Yeah? And with microservices, including this problem all the time. Another one is difficult to trace data flows. If you have several services that interact with each other to provide some functionality, and something happens, a bug, a system misbehaves, you need to be able to trace the sequence of calls to decide what happened. Okay, so how the data flows from when the input comes from the user to the output, what happened in between, which service were involved, with what calls. This is another level of complexity. For these things, often you use some kind of correlation IDs, things that are actually an ID that associate to each step of the process, so you can at least see the logs and see what happened. But again, another layer of complexity because you have to pass this at all levels of your services. Yeah? Performance issues. Performance issues can be quite difficult sometimes to actually pin down because they're in a network now. So first of all, testing performances is much more complicated because you have to basically create the system with, if you want to test what the theoretical performance would be in a production system, you either do that in the production system or you have a parallel one the same size. And even if you are talking, not even 100, but even say 10 services, already comes with lots of challenges. Okay, and then if you want to make it more performant, the fact that you have a network in between potential delays and misconfigurations make the whole thing much, much more difficult. Okay, when you are testing a single program, it's much easier in general. You don't have all the networks, you don't have all the communications there. Yeah? And these are all typical issues that most teams encounter when they are starting microservices or with any kind of service-oriented architecture. Because, by the way, microservices is not that they are special. It's just distributed system, but in theory, each service in the system is so small that can be, what they say, developed in 1 week or something like this. Yeah, but it's still a service-oriented architecture. And so, you know, the thing is, with all these potential issues, they are not a panacea for everything. Okay, so you really need to know when you can actually should use them and why. So the first thing is, this is a quote I put a link when I distributed slides, and it's from Basho company. They do React, distributed NoSQL database. So when should you use microservices? When you're ready as an engineering organization. Which means, now we'll talk a bit more depth about the various aspects here. So basically it's not simply, I'm reiterating a bit what I said before, it's not simply going for this particular architecture, there is some stuff that needs to be there. So there are some technical aspects. First of all, you need to automate everything. Yeah? That if you have tens of services, having anything manual is going to be extremely difficult. But I can say also from experience, also if you have only 5 services, anything manual for the deployment or updating or stuff is just going to be a big waste of time and potentially error-prone. And automation actually requires a lot of work, lots of preparation, lots of planning, because you need to start early on. Typical mistakes many teams make is that at the beginning they don't really automate everything there, or don't really prepare the ground for automation if they're in that direction. And then you reach a point where you say, gosh, you know, our continuous deployment, the continuous deployment production is actually 1 week for the deployment time because we have all these things. Yeah. Consistency. Consistency means you need to reduce the cognitive load of the people involved in the work. Means using naming conventions, using patterns, using ways when you design your service to actually keep making similar things similar. Yeah. So if you use the same patterns, the same naming conventions, it will be easier to actually understand what the different services do. So in a way, consistency goes a bit against the use the best technology for the work. There is a bit of a tension there. Yeah. But if you write one service in Java, one in Ruby, one in Python, one in C++, another one you write it in, I don't know, in Kotlin just because you want to play with Kotlin, the problem is it will be difficult for people to actually put their hands in all the different bits of the system. So there is a bit of a tension there between, you know, the best technology for the job and actually being able to work with the system running. Yeah. Version control. Everything in version control, absolutely everything. So code, networks, documentation, host in the same repository. So if you have different services, probably each service with its own repository because you want to deploy them differently. Whatever is related to that particular service has to be in the version control. Yeah. I typically recommend also for anything related to documentation, just don't put that stuff in a separate wiki and then version control the rest. You want everything in the same version control system. Also that kind of documentation. So you have something that evolves with the system as well. Remember that now you have many moving parts, so you don't want to waste your time digging for information for each of those. Protocols. Now this is interesting bit. So you know when the separate deployment, not influencing the other services, everything's always up and running, but the services have to talk with each other. Yeah? Because if they don't, you don't have microservices architecture, you have actually several separate applications, which is a completely different thing.
What do you mean by protocol? Are you talking about the REST API, for example?
For example. So protocol, so a REST API is not sufficient to say we are using REST. It's also what URL are using with what query parameters and what kind of body you are sending. Is the format of the JSON, XML, or whatever proprietary format you send the messages. The services that talk with each other need to basically speak the same language. Yeah? Which means that to have all the protocols, you also have to do some more work there because you need some versioning. And probably you need to support several versions of the same protocol at the same time in many of your services. And the reason is, if you update from version 1 to version 2 of a protocol, okay, and you support only version 2, the problem is you force the redeployment of all the other services that depend on the same thing, which is what you want to avoid with microservices usually. Yeah? So you probably have to have a system of web. You have to have a system web of versioning and supporting several parallel versions at the same time. A typical problem for, I can give you an example. It is not necessarily microservices, but in terms of protocol versioning, is if you have any backend service with a front-end app, you have an app in the App Store, in the Google, or in the Android one, yeah? And they talk REST with the backend servers. What happens with the apps is that when you evolve the server, you cannot expect the clients, and even if it is under your control, to evolve in lockstep. Yeah? Often that is, you have to think at least a minimum of 6 months to be able to actually port everything to the new protocol, and also you cannot expect users to actually update continuously, yeah? And you cannot even force them to do so. And if you try to force them, they'll probably abandon you for some competitor. Yeah? So in those situations, what you do, you evolve the server, and you, for a while, support several versions of the same protocol. Yeah.
Okay, so you have, say, 10 microservices, and each of them has supporting 2, 3, or 4 versions. You can have a massive combinatorial.
This is where some of the work needs to be done. Basically, you need to be able to manage that and evolve them somehow. Okay? But what you don't want is to update them, all of them, at the same time because of a change in protocol. This is one part of the price you have to pay. Manage this. Manage exactly this kind of potential combinatorial explosion. Yeah? And this is even worse if you expose some of your APIs to other services that are customary. Yeah, they are outside your control. Yeah? I don't know, Amazon APIs, Google APIs for something. Probably some of those will live for a long, long time, and probably they will have several parallel versions at the same time. Yeah? And then you need some room for experimentation, obviously. With this added complexity, things you probably need also some slack to be able to actually try things out and see which one works, which ones work and which ones don't. Don't expect to be able to do any big design up front with this. I mean, it doesn't work with a single application. When you have multiple like this, it's going to be much more difficult. Okay, so and then there are some organizational aspects. So again, mentioned before, team dependencies, teams that need to work together, how to organize them, how do they communicate with each other, how do they actually work to provide the functionality for the users. So typical problems you may include is that if you have parallel teams collaborating to implement their own services, something that from a user point of view is a single piece of functionality, yeah? How are you going to proceed to deliver that? So the typical problem is the teams will never be in full sync with each other. It's a distributed system, so you have to expect delays and failures at some point. So even the teams themselves interacting there with the system. Which means you need to design also a system in a way that allows you to have something like feature toggles or the equivalent. So basically switch the functionality on when everybody's ready. Yeah? But you cannot plan expecting to have everybody's in sync at the same time. It's just not going to happen. Yeah? Which incidentally seems a kind of expectation that some of the agile, safe guys have. So the team dependencies cause also some technical problems that we need to address. Okay? Also, there are situations also in terms of code ownership. So you can have different models. You can have different teams with different services, so each team owns its own code, but sometimes there is collective code ownership. But with collective code ownership, there are also other issues. So depending on the services you have, it might be actually difficult for developers to know sufficient details of all of them. Yeah? And some people think that one of the disadvantages could be that if my team is working on several of these services, actually we may know some internals of one of the other services, and instead of going to the official protocols, we go to the backdoor. But this, I don't think that is a serious problem. It's more kind of, to me, sounds more like managers being afraid of developers, typical thing. Yeah. But there are issues. Or if you try to collective code ownership, but the services are in different, written using different languages, using different technologies because of some specific needs. All these things have an impact. Yeah? Architectural governance. So sometimes microservice architectures without architectural governance just grow organically with a forest of services, and at some point people just don't know what services are doing what, and which ones are actually useful, and which ones are not used anymore. So still having architectural governance means having a vision there about the system design, how the system should be composed and how the things fit together. Okay, so even if it's a distributed one, at some point you have to have a single understanding of how all these things fits together. Yeah? And then also the requirement streams. Depending on how you organize your services, managing the requirements can be, if the functionality needs to go through several services, you have the problem with the teams, implementation, and things like this. So maybe if you want to be a bit more decoupled and be able to deliver better functionality, if you have the services actually split along some kind of domain lines, functionality lines, in a way that depending on what you have to do, you don't really need to talk with a gazillion services, but only with a few of them, maybe just one. Then you potentially have lots of parallelism there and fewer dependencies. But again, this depends. It is still about architecture and system design and how you grow your system.
Do you have any thoughts on monorepos?
Well, I don't have any specific. In general, it depends. I know that Google uses a big repo successfully. I never worked for Google, so I don't know how it works for them. I think that in general, to split repositories, you have to have very good reasons. Yeah, because let's say that if you have a service that is composed by a UI, and UI, let's say a web UI for some admins of the service, and the service itself, probably these two should live in the same repository because they will evolve together. Yeah. But if you have different services that actually have different deployment timelines, you may want them to be in separate repositories. What you don't want is separate repositories for things that are always deployed together, because that adds complexity without really giving you many benefits. So it depends very much on the situation in which you are. I've seen the previous system I've come across, it was when I was consulting something about repositories, not necessarily about services, but they had basically a single product. They probably had a few services, but just a few, but they had 2,000 Git repositories. Now you can imagine a release for that thing, utter madness. And then obviously a matrix of compatibility of which version of what. So that is just an addition of complication. So it depends. In that terms, I would say if you have different timescales, you probably want to have different repos. Yeah. But also, since you have the problem with the protocol, maybe you want to have repos. Let's say if you simple model with two services that talk with each other and have different deployment times. Still, you have got the protocol that they communicate with somewhere else. Yeah. And there you might need three repos. So maybe one of the services on the protocol, but there are things you need to address there. Yeah? If they evolve at different timelines, I would say the monorepo is going to get in the way.
I wanted to just mention the question of not just ownership of code, but ownership of actual deployed instances of services. We've seen cases where owners of those services were unaware of who's exactly using them, and therefore decided to change an API or turn something off, and ended up breaking something half a globe away.
That's a very useful way of doing things if you want to understand who is using your service. Then everybody will, because sometimes you ask, nobody answers. You break the service, everybody calls.
Shouldn't the API be owned by the architect? Should the API or the protocol be owned by the architect? You mentioned architectural governance, that's true.
Well, but the architect, who is the architect? Because architectural governance doesn't imply a person, it implies order, which the architecture can be shared by the teams, for example. Nothing wrong with that. So, in a way, it depends also to what is best for your specific circumstances. There is no real right and wrong answer there.
Can I just confirm that then? When you say architecture of governance, I will read that as being you need somebody there to actually approve for it to be rolled out.
Not necessarily. No, it's not. You don't necessarily need that. What you need is people that are on the same page and know what they are doing, which is a slightly different problem.
That's not governance, that's shared ownership.
Well, but there is governance because you know what the system does and how it is shaped.
But governance is where an organisation governs what that is.
Yeah, but it doesn't imply one person deciding that. It could be an agreement among the teams. There could still be a governance for that. The problem here that you want to avoid, the situation where services pop up all over the place and they are used, you don't know who uses the service anymore because there are people that are using that without even notifying you, so you don't even know if you are going to break anybody. You want to avoid these kind of situations. Okay, so it's more about knowing what you are doing.
I appreciate the sentiment about just confusing when you use the word governance in a title somewhere.
Well, but here what I mean is that the shape of the system is known and is evolved in a specific way because people know what they are doing. So it's just the avoidance of chaos. Okay.
One way I've seen this addressed quite successfully is where users of a service need to apply to have an API key issued to them. That's why you've got to register, and it's renewed every so often.
So you know who is using the service and you know who not to notify. Any other comments, questions so far? And so, as I was saying already, you need to actually take a systemic view. Okay, so it's not simply, even if the services can be maybe deployed independently from each other, you still need to have a system view of what the system provides, yeah? Because when you have many services anyway, you cannot turn on and off the system the entirety of it. But maybe sometimes your computing center crashes, but it's not really turning it off, it's most of it's actually a problem. So you have to work in a situation where you have to assume that the system is always on, and parts of it will be failing. Yeah? One of the characteristics of apparently of distributed systems is that they are all perennially in failure mode somewhere in the system. Yeah? And you need to design the system, evolve it in a way that is actually supportable, so that when it's running, I actually know what is happening. If something bad happens, if I'm notified of an issue, I'm able to actually, I have the tools that allow me to check what's going on and decide how to fix the problem, which is not easy at all. Or testability. Testability is essential. Testability is always extremely important. In this case, it's fundamental. Okay? Because here in testability also I mean with proper automated tests at all levels. I'm not talking about manual testing. That is, manual testing for me is more about exploratory testing. It's something you need to do, but it's just one thing. With these kind of systems, you cannot really do a lot of that if the system is very complex. So you probably automate lots of testing. And you need a situation where anytime you modify, you add a new service or modify service, you're able to actually write some automated test to check that the expectations you have for the service are met. Okay? Which means designing the services also with some testing hooks or testing APIs. In a way they can be seen as backdoors to the system, so I can actually test the system and see that it's working as expected. Okay? So in some systems that use REST, sometimes you may have some entry points that are simply not made public. They are behind the firewall and they are used only in your development environment. Yeah? These kind of things. But obviously it's essential, but it's also more difficult. Yeah? You have more things to test, and many more things can go wrong. Or think also performance requirements, or disaster recovery, or testing the availability or resilience of your service becomes much more difficult. Yeah, because you have several scenarios. But you have to work towards a situation where you can test as much as you can in an automatic way, which means designing the system in a, which in my experience, if you actually use an approach that is towards, even if it's not full TDD, but at least test first, will help you create at least the right APIs for that. Yeah. And something I mentioned before, remember that the distributed systems have surprising failure mode. So diagnosability and correlation IDs and these kind of things are extremely important, because it doesn't matter how much you tested it or how much confidence you have. Sometimes there are some strange interactions that happen and you have a major failure and you really couldn't predict that. Okay? So the more work you do to make your system diagnosable and give you an ability to actually look into it and correlate things, the better you will be when bad things happen. And also, said, okay, we want to go microservices, but some guidelines on how to do that. Well, the guidelines for adoption are always the same, means always the same for guidelines for adoption for any new technology, or any, also old technology, any technology. Know why. Why do you want to do that? What are you going to get out of it? Yeah? What problem are you trying to solve? Why do you, what benefits are you going to get that will actually justify the price you have to pay for it? Yeah? Because we have seen that the price can be quite high. Yeah? Adopt incrementally. I spend a bit more time on this, but basically means just don't try to say, okay, design the system full on the beginning, we'll go with a microservice architecture with 20 services. Start from one, yeah, and get some knowledge about your system. Avoid premature structure. So which means, this is about the splitting of the domain and things like this. Start, again, small, and then as you understand the problem better, you can structure it more. Invest in tooling and support and align the organization.
I would add invest in training.
Yeah, as well. Yes. So, as some first steps, again from Basho, something, I think this was a blog that wrote this, the single most important step on the path to a solid, workable approach to microservices is simply understanding the domain you are working in, which is more difficult than what it seems. In all the domains I worked on, the domain experts I worked with usually didn't understand the domain well enough to actually be helpful. They needed, basically we needed to build things incrementally also for them, not only for us, but also for them to get a better picture of what they wanted. And this is normal because if you think when you're building a new system for something or evolving an existing system to do something new, to an extent there is some novelty in the domain as well. Yeah? In software, very rarely we redo the same thing. Yeah? There are a few startups that try the new Facebook for blah, 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 but usually we do something with some new elements, which means that also the domain there is an element of exploration also for the experts. Yeah? Or sometimes I found out in some projects that actually the domain experts were not really domain experts, as in this is a well-known domain where there are people at conferences and they talk about this and they know what they are talking about, are more people that have worked in a specific system for 20 years. So for them, the domain is whatever was implemented in that system. Okay? And in projects where I've been, where we tried to create a new system, it was very difficult actually to interact with these experts because anything that was new, that was potentially outside that particular view of the world was very difficult for them to understand. Yeah? An example again is security, travel security thing. For example, in that particular context, something that is extremely difficult to model is the concept of where is someone. Because you can track with mobile phone, but sometimes the mobile phone is off and you have travel information about airplane times, train times and things, but you cannot be sure that the person has taken the plane or the train, or there could be delays. Okay, so they had some preconceived notion of this where somebody is based on the old system, but there were some holes in this notion in terms of actually this person may die because of your assumptions. This is real, I mean, so, and then we propose other ways that was more based on, look, we really don't know, so what we can do is, according to the information we have, this person could be anywhere in these places. Contact the person, stuff like this, but again, these kind of conversations are extremely difficult and painful because for someone that has worked 20 years with a specific system, with a specific concept, there, things was very difficult to understand the implications. Yeah? So understanding the domain is not always that easy. Okay? So the best way to generally understand the domain and do everything is actually start small. This comes from from the Systems Bible. I really suggest this book. It says a complex system that works is invariably found to have evolved from a simpler system that worked. How many of you have actually worked on a system that was a big design up front with very complex and actually was created and worked? I've never seen any. I mean, I've seen many attempts, and then, you know, horrible failures. But this is basically the approach. So now, when people talk about microservices, there are kind of two schools of thought. I belong to the start with a small monolith. Start with one application that solves a problem. Monolith as in not a big ball of mud, as a well-designed modular system, but one application. Okay? And by the way, as Simon Brown says, is a software architect, quite well known in the community, says, if you are not able to actually design a modular monolith, forget about microservices altogether. Because you are adding to, you are introducing the problems, but you won't be able to design a better system. Yeah. Automate early. So from the very beginning, first thing to do, all the automation pipeline, the CI pipeline, it doesn't have to be complicated, but at least the initial things you need, start from there. Okay? Because the problem with automation is, if you start early and you set the stage for automation, it will be actually relatively simple to evolve it according to your needs. But if you start late, you end up in a situation where you really don't know how to proceed. Yeah? In terms of any build pipeline I've seen. All the legacy systems I worked on that didn't automate early, there were always discussions about we should automate, we should do this, should do that, and it was never done because it was actually very difficult to actually find the starting point to do that. Write tests and code at the same time. So before there was a question about developers writing tests, if it was better to leave this to the experts, to testers. Yeah, a question to you was there. Now, I'm a developer, okay? I don't come from testing, I come from software development. And what I can tell you is that if you try to write your tests first, you look at your system in a different way. You start asking different questions. You probably won't find all issues, but you'll find all the most important ones. Because it's just a different approach. You start thinking, okay, what do I want here? First of all, what kind of code I want here? Yeah? How do I want to do this? And then you start writing your test, and you realize that in order to have the system testable, you don't want to write 20 pages of setup code and stuff like this. You want it to be simple. And so you actually think about how you are going to test it and also how to design it in a way that is testable. Because fortunately, developers tend to be very lazy. And then you start asking questions, because the simple act of doing that, then you start discovering, hold on a minute, there is this corner case now, what should I do here? So if you do this at the same time, chances are you'll have a better system to start with. Yeah? Design application around service boundaries means basically don't go into when you are implementing functionality, don't implement it into layers. We do the database layer first, and then the domain layer first, the second, and then blah, blah, stuff like this. Doesn't work. What you have is layers that, when you look at them, they look very nice, simply because they're consistent in design. Then you try to use it from the layer above, and you think, damn, doesn't really do what I need here now. And then you start hacking your way around to use. Instead, if you go around services, so you say, this is what I want to actually achieve, yeah? This is the kind of call I want. How do I implement that? And you go through end to end, yeah, and implement the bits of each layer as you go. What you'll have is that your layers will evolve according to your needs, and in the meantime, you'll actually be able to deploy stuff that works for your users. And this is actually much easier than what it seems. Okay? And then work iteratively and incrementally. Now, I've got a feeling that many programmers, or many people actually, confuse the two terms, iteratively and incrementally. They're actually very different. So, iteratively means you don't try to be perfect the first time. What you do is, you do something that kind of works according to your current understanding. Somebody looks at it and says, yeah, it's about right, but here I want this a bit like that. And then you have another iteration until the thing is better, okay? This is about subsequent refinements of the same thing. Okay, so you don't waste time trying to design something in full at the beginning when you don't really, without any feedback from the ground, okay? And by the way, if you work in an iterative way, what happens also is that at some point you'll stop, and probably you'll stop much earlier than what you think, yeah? You can get away with much less. Incremental is about adding on top, so it's about adding new functionality on top of existing functionality, okay? So the iterative bit is about a single piece of functionality, making it better and more refined, or you gain more feedback and a better understanding of the domain, and so at the end you get what you really want. The incremental is you add a new piece of functionality on top of that. Does it make sense? Yeah. And this is, I see many agile teams that don't really understand this. They try to be perfect with each piece of functionality for the first time, and then they have problems. Yeah. And as it happens, this was my last slide, 23 minutes, 24 seconds early. But we have time for questions.
Now, because we gave you a little bit of late start, we are actually, according to our schedule, just 14 minutes ahead, so we are doing all right. There will probably be 14 minutes of discussion, although I don't want to force that if you are all feeling stupid or stupefied or whichever you want to look at it. By all means, but we have a good 14 minutes to discuss with you all.
So, have you any guidance on when to split services out from the monolith?
The thing there is, when you decide, when you're thinking about splitting, is about, you must have a problem that requires that. Okay, so the when is, what problem are you trying to solve? So for example, you may have two chunks of functionality that you decide to sell different quality of service. Yeah, for example, you may want to split that because maybe you want functionality that has to be very low latency and something. This for the other you don't have. And maybe you want to split so you don't have a single system to accommodate both of them, for example. Or you have an issue with the deployments of these parts of the system, and you want to separate them. But the when is when you have a problem to solve that actually can be solved by the splitting. So it's not like, there is not a, because if you don't have a problem, just keeping one system instead of two, you are probably much better off by that.
Can you give an example? Can you give an example?
Of what?
Of what you just described?
Well, let me think about, the system we were working on, the one I use as an example is just because it's very fresh. That one, for example, instead of starting microservices, could have been one system, and actually could have been by us being one system for a long time. Okay? Before then splitting into different services, depending, like, the one I said about the travel security, instead of having 4 or 5 services, to the point that we actually merged several services back. Yeah, and at some point we said, oh, probably should have been one system anyway. Because there was no need of separate deployment. Actually, the deployments needed to be most of the time at about the same time, for example, which added lots of overhead. Yeah? Splitting, maybe at a later point in time, if there were some situations saying saving the travelers connected with a mobile phone and tracking them in the system was going to be expensive because you have 500,000 people to track, and maybe there are continuous calls to the system. Maybe you want that to be different from the other one that is a bit more static on country intelligence and some other queries related to other stuff, for example. Yeah? But until you reach the point where you actually see that there is that need, you are probably much better off to keep everything together, modular, okay? And just go with that. Also because that system was deployed on Amazon, we used Postgres as a database, and we had Amazon for Postgres supports replication of the database as well, which meant that in fact we could also scale the same instance of the process many times, yeah, with the replicated databases without having to do much work there. So there wasn't a real need for many things. Yeah, but then, as I said, later on things might change, and they may decide to actually split those for good. Yeah, in this case, because of quality of service.
I can provide an example where it is a good idea.
There is one near the whiteboard you said.
I'll both wear the British microphone at the same time.
Well, you can use one of the whatever.
So this is an IoT application where you have lots of devices out in the field, all reporting via the cloud into a database, or into a server. Thank you. IoT application used for measurement of movement of goods. So all these devices here were reporting in. And the important thing was that whenever one of these things updated its location or whatever, it got a response very quickly. Because all these things were contending for the same service. So using the same service to also answer questions by operators, you know, where are my goods, was not a good idea, because these could be quite long-lived queries while it goes and assembles data from lots of different tables. So there it was a very good idea to split them up and actually have a queuing mechanism that just accepts these queries, these updates very quickly, stuffs them into a queue, and then writes them to the database in sort of background time, and having a separate process which then uses the database to answer queries.
So I have a question about, is licensing a particular problem with microservices, in that if you're trying to avoid shared resources, it seems a better fit for, say, an open source data persistence than a commercial database where the impetus is to share resources because of licensing restrictions.
You know, I guess licensing restrictions are one of the constraints that you have to consider when you design your system. So yeah, that would be, that is a system constraint that you have to keep in mind. I remember now, I don't know how it is nowadays, but I remember years ago when I was using Oracle in another place that the licensing was really crazy. It was a multiplier of number of processors and cores and stuff. So to go from £1,000 to £1 million was really simple. It was very an exponential thing. So I think the licensing is in a way a constraint. So that will probably dictate what it can achieve. You know, so it's not necessarily an impediment to microservices, but if you say, you know, this would be the best architecture, but to get that, with the tools, with the licenses we would have to pay is actually too much, we cannot afford that. That is mostly a system constraint and a business decision. Yeah. So you may then want to settle to a lower level of service that is more cost effective for your company. But, you know, the licensing, like everything else that influences costs or infrastructure or even the skills of the people, you know, these are all things that dictate that put some constraint in what you can do.
Yeah, thanks. So I'm trying to visualize what happens if you started with a massive monolith or monolithic application. Okay. So you start off with a monolithic application, and you, for some miracle, you identified a well-defined microservice on a split off. So you start with a single code base. Are you saying you should fork that code base and split it into the two teams?
No, what I would suggest, my suggestion there would be, now if you decide that you need to split the services because of theoretism for that, okay? You don't need to have two teams, but to start with, you don't need to start with two repositories. What I would suggest is the first step, keep everything together, because you know, you'll probably have a situation where you think you know exactly what you need to do, but then you discover some other things. So first step, you just try to actually disentangle what you've got, and then at a later point you fork off. And at the beginning it would even be the same thing, you know, two services would be fine. So adding teams and adding services is one of those things that has to be done extremely carefully, especially the adding teams. Yeah. Exactly.
I thought the point about collective versus service team ownership was a really good one. That's something we're facing in our company at the moment, is the problem, which is not necessarily microservice related, but the problem of code silo. And I think microservices exacerbates the problem, because once a team owns a microservice, then you've effectively, the boundaries of that service are even more well defined. So I don't think that there's a right answer to the collective versus service team ownership. But I don't know if you, in your experience, you found one favourite one or the other.
My experience in general is my experience also from my consulting. I joined Zurich only 1 year ago. Before I was for many years a freelance consultant. I actually had some large teams sharing code or services or stuff. My experience tells me that when you have different teams sharing the code base, you're going to have a problem because they will step into each other's toes. Okay, so that's just is going to happen. Yeah. Even if in the code is modular, that is going to happen because there will be something at some point with mergers and things. So in general, if you want for different things, it's better to have some kind of separate code bases. Now the question is, how do you want to organize your teams? You have component teams or service or feature teams or what? And this is interesting because in the J community there are people obsessed with feature teams, and generally the obsession comes from not actually understanding technical things. They are the best because feature teams are the best, and by the way, I haven't written any code in 20 years. So as far as I'm concerned, the guy could go without, as Boris would say. Yeah? The thing there is, at that point, if you want to have feature teams, you probably have to have services around the domain boundaries, around features. Okay, so basically there is still a correspondence in between services and teams, but it's not components anymore, so you limit the interactions. Since we are talking about an architecture that is the same system, probably, or actually surely, you will have some component teams as well, because there will be some common infrastructure at somewhere, and somebody will need to manage that. Okay?
Yeah, so the platform teams.
Yeah, and the funny thing also with services, if you think about it, is that what happens with the service architectures is that at some point you have made the situation where your component is actually my service. So I've seen situations where something that was being the component of a service becoming stuff that was sold to clients. Okay, so that was functionality exposed now, so it's a service. But it's a service if you look at it from here. If you look at that from here, it looks like a component instead.
Yeah.
Okay. So these things actually make the picture a bit more complicated.
Yeah, so I think I've lost one on that, but yeah, like I said, there isn't a right answer to that, but yeah, it's an ongoing conversation that we're having within our company.
My personal experience in this to solve the problem is actually if you have people that, if your technical guys know what they are doing, yeah, what you need to do there to start solving the problem is grab the managers that don't write any code and just, with an excuse, send them away for and leave the teams alone, they will solve the problems. Because often what they've seen is that instead managers that actually in good faith trying to intervene, and what they do, instead of helping, they add lots of structure and hierarchies and coordination and stuff. And people that actually do the work have even more problems in doing their work. My team cannot talk with Timo's team because we affect each other's capacity. We have to go through Will because he has to escalate. And this is usually what happens if you start